Number 1. Complete the table below converting from degrees to radians and radians to degrees as necessary. Leave your answers in terms of pi. Well, the most essential thing that we need to know is that 180 degrees is equivalent to pi radians. When I say 180 degrees, we need to be thinking of pi radians. When I say pi radians, we need to be thinking about 180 degrees. Once you know this relationship, the conversion is really straightforward. So, 45 degrees. I have 45 degrees times what? Well, I need to get rid of my degree unit, so let's put that in the denominator. 180 degrees in the denominator, pi radians up top. Well, 45 divided by 180, if I write that as a fraction, I get 1/4 times pi, which is pi over 4. So 45 degrees is pi over 4. And that's one that you want to know. All your pi's over 4s, any multiple of that, has to do with a 45-degree reference angle. So your pi's over 4s all have to do with 45-degree reference angles. 120 degrees. Well, I have degrees, so 120 degrees times what? I have degrees, so 180 degrees goes in the denominator, pi radians in the numerator, because pi radians is equivalent to 180 degrees. What's 120 out of 180 as a fraction? That's 2/3. So this is 2 pi over 3. That's 2 pi over 3. 2 pi over 3 radians is the same angle as 120 degrees. This time I'm given radians. I'm given negative 5 pi over 6 radians. Well, I have radians. This is a radian unit, so I need radians in the denominator. Pi radians times 180 degrees, desired over given. I want degrees, I have radians. Well, pi divided by pi is 1. You could type this into your calculator, but 180 divided by 6 is 30. So negative 5 times 30 gives me negative 150. Negative 150 degrees. 3 pi over 2. I'm given radians again. 3 pi over 2. That's radians. 3 pi over 2 times I need to get rid of radians, so pi radians in the denominator, 180 degrees in the numerator. Pi divided by pi is 1. 2 divided by 180 is 90. 3 times 90 is 270 degrees. 3 pi over 2 is the same thing as 270. A quick way to do this is to plug in 180 for that pi, because pi radians is 180 degrees. 450 degrees. I'm running out of colors here. Let's go to this dark purple. 450 degrees. It looks the same. We'll go to orange. 450 degrees. I'm given degrees here, so I need to get rid of those degrees. So that means degrees has to go in the denominator. Pi radians goes in the numerator. What is 450 out of 180 as a fraction? Well, you can use your calculator and hit the math frac button. 450 out of 180 comes out to be 5 halves. This is 5 pi over 2. Notice that it makes sense that this is bigger than 2 pi. Because 2 pi is 360, clearly this angle is larger than 360, so this angle should be larger than 2 pi. So, converting from degrees to radians is essential to understand, and all you have to do is know that relationship. 180 degrees is pi radians. From there, you can get to any angle that you want, knowing that relationship. Consider a circle with a radius of 3. Well, there's my circle. Let's make it have a radius of 3. Still have the orange. Radius of 3. A sector of the circle has an arc length of 2 pi. I have no idea how large this sector is, but the arc length, the arc subtended by that angle, has a length of 2 pi. Determine the measure of this angle, determine the measure of the angle of this sector in radians. So I want to know what that radian measure is for that angle there. In Common Core geometry, you solve problems just like this, except you use degrees. Now we're using radians. But it's essential to understand A radian is how many times does the radius go around the circumference of actually on the circle. You can memorize the formula S equals theta r. Arc length equals angle measure times radius. So 2 pi equals theta is my x, my radius is 3. Divide both sides by 3. 2 pi over 3 is x. Now, considering this is the first day that we learned radians, 2 pi over 3 probably doesn't mean much to you. It takes a little bit of time to get used to what 2 pi over 3 radians is, to make that connection to what the degree measure is. So let's convert it. 2 pi over 3 times, I have radians. So radians goes on the bottom, I want degrees up top. Well, that's 180 divided by 3 is 60, 2 times 60 is 120 degrees. So my angle measure, this angle is 2 pi over 3 radians, which means I need to go 2 pi over 3 radiuses around the circumference of the circle to get that angle, or it's 120 degrees. Either way to think about it. But knowing S equals theta r is important because it's really just a circumference formula. Circumference equals 2 pi r is a special case of this relationship here. The circumference, the total distance around the circle, is 2 pi radians. If I go 2 pi radiuses, if I take the radius and go around the circle 2 pi times, that gives me the circumference. So circumference equals 2 pi r is really a special case of S equals theta r. Explain how radian measure is related to the radius of a circle. It is essential that you understand what a radian is. So let's say I have a circle here with a radius of r. What is a radian? Well, think of our pipe cleaner. We measure this distance, and we pick up that distance and spin around the circle. So that we get that distance, this is a guess here, so the distance, the arc that we traveled, it has the same length as that radius. Once I draw in that angle, this angle measure is 1 radian. Why? Because I took a radius and I traveled that distance on the circle. Doesn't matter how big the radius is, doesn't matter how big it is, doesn't matter how small, how large it is, that angle is 1 radian always. If you take a radius, spin around the circle, you get 1 radian. This goes back to the fact in geometry you prove that all circles are similar. All circles are similar. If I dilate a circle about the center of the circle by any number, the angle is preserved. 1 radian is taking the radius and spinning around the circle that distance on the actual circle. So explain means write a sentence. You should have some kind of sentence written on how we take the radius and spin that far around the circle, and that's how we define 1 radian. Number 4, compute the values for the following expressions. The sine of pi over 6. Now, clearly this is a radian measure, but how do you know it's definitely a radian measure? Because you'll see sine of, let's say, 120 degrees. I'll always include the degree symbol when I'm talking about the sine function that inputs degrees. I won't include a degree symbol when I'm talking about the sine function that inputs a radian. Pi over 6 is a radian angle measure, and this is one that you gotta memorize. Pi over 6 is important that you memorize. What is pi over 6? Well, times 180 over pi. 180 over 6 is 30 degrees. So pi over 6 is 30 degrees. What is the sine of 30 degrees? The sine of 30 degrees is 1/2. How do you get that? Your lovely special right triangles. Your special right triangles is essential to knowing sine of 30 is 1/2. But what I want you to really know is pi over 6 radians. Pi over 6 radians is 30 degrees. Because if you know that, things become a lot easier going forward. Cosine of pi over 4. Pi over 4 might not mean much to you right now, but it's something we need to get comfortable seeing. Times pi 180 over pi, because I have radians, I want to get rid of radians, and I want degrees, so desired over given. 180 divided by 4 is 45. What's the cosine of 45 degrees? Well, if you make your unit circle, look at your special right triangles, you see that it's radical 2 over 2. That's great, but what's really important is you know that pi over 4 has to deal with 45-degree angles. Just as pi over 6 deals with 30-degree angles, pi over 4 has to deal with 45-degree angles. Sine of pi over 3. It would be nice to know what pi over 3 is. I have radians, I want degrees. I want green. The green marker. Pi over 3 times, well, I have radians, I want degrees. 180 divided by 3 is 60. So I have 60 degrees is pi over 3. The sine of 60 degrees is radical 3 over 2, and that comes from our special right triangles, whatever way you want to get that radical 3 over 2. What's more important is what is pi over 3. Pi over 3 has to deal with a 60-degree angle. Pi over 3 and over 3 has to deal with a 60-degree. Pi over 6 deals with 30, pi over 4 deals with 45, pi over 3 deals with 60. And finally, we have the sine of pi over 2. Well, pi over 2, well, pi is 180, pi radians is 180 degrees, so if I split that in half, I get 90 degrees. What is the sine of 90 degrees? Well, I'm going to make a unit circle here. Spin 90 degrees. That point is 0, 1. Sine is y, so sine of 90 is 1. So the sine of pi over 2 is 1. Number 5, compute the values of the following expressions. Sine of 7 pi over 6. There's a couple ways to think about this. The first thing that I notice is over 6. A pi over 6, I know that pi over 6 is 30. Pi over 6 is 30 degrees times 7. 30 times 7 is 210. Another way you could have gotten that is by saying pi over 6, 7 pi over 6 times 180 over pi. You get the same answer, but knowing pi over 6 is 30 degrees saves you a whole bunch of time. So what's the sine of 210 degrees? Well, I'm going to spin 210. I truly care about my reference angle, which is right there. What's nice about radians is that pi over 6 clues me into my reference angle is 30 degrees. My reference angle is 30 degrees because that angle in that triangle right there, I spun 180, I have to go another 30 degrees. But we're in quadrant 3. In quadrant 3, both cosine is x, and sine is y are negative. So that's negative sine 30 degrees. Well, sine of 30 is a half, so negative 1/2 is the answer. Cosine of 7 pi over 6, well, we already did most of the work. Our reference angle is 30 degrees. We're in the third quadrant, so it's negative. So it's a negative cosine of 30 degrees. If the sine of 30 is a half, that makes the cosine of 30 radical 3 over 2. And it's negative because I'm in quadrant 3. Sine of 5 pi over 6. Make a unit circle. At least make the sketch for a unit circle. 5 pi over 6. I'm not really comfortable with radians yet, but I notice it's a pi over 6. Pi over 6's have a reference angle of 30 degrees if you want to memorize that. Or you could say 5 pi over 6 times, I know that pi is 180, pi radians is 180 degrees. That gives me 30. 30 times 5 is 150. So 5 pi over 6 radians is the same as 150 degrees. So I end up in quadrant 2. I'm spinning 150 degrees. What's my reference angle in my triangle? Well, I spun 150. I've got to go another 30. So my reference angle is 30 degrees. In quadrant 2, my x's are negative, my y's are positive. Remember, x is cosine, y is sine of the angle, so its sine is positive. Sine of 30 is a half. I knew that I would be using a reference angle of 30 from that pi over 6. What is the cosine of 5 pi over 6? So that's the cosine of 150, which is the cosine of 30, because that's my reference angle. But I'm in quadrant 2. I'm in quadrant 2, so that makes it negative. So it's not just the cosine of 30, It's minus cosine of 30 degrees, negative radical 3 over 2. Okay, so when in doubt, convert your radians into degrees. It's never going to hurt to take your radian measure, convert it into degrees. Number 6, if 0 is less than or equal to theta, which is less than 2 pi, so number 6, if 0 is less than or equal to theta, which is less than 2 pi, this is key for saying use radians. If they didn't, they would say 0 to 360. What are possible values of theta if the sine of theta equals negative square root of 3 over 2? Well, I notice that sine is negative. Where is sine negative? Sine is my y values. Where are my y values negative? They're negative in quadrants 3 and 4. That's where my sine values are negative. I have sine of theta is radical 3 over 2. Well, what angle, the sine of what angle gives me radical 3 over 2? Well, the sine of 60. The sine of 60 degrees, because I'm comfortable working with degrees, gives me radical 3 over 2. So, what are my angles in quadrant 3? Here's my quadrant 3 angle. If that's 60 degrees, how far did I have to spin? Well, that's 180 plus 60, so that's 240 degrees. In quadrant 4, because that's also where sine can be negative, that has to be 60 degrees, so I have to spin how far? If that's 60, my angle is 300 degrees. That didn't answer the question because I want to know what theta is between 0 and 2 pi. So, how do I convert 240 degrees into radians? Well, I need to divide by degrees. 240 over 180. Use a calculator if it helps. Use a calculator if it helps, and you get, at math frac, you get 4 thirds pi. You get 4 thirds pi, so that angle is better known as 4 pi over 3. 300 times pi over 180. That gets rid of my degrees for me. 300 over 180 that's your 5 pi over 3, your 5 thirds pi, which is 5 pi over 3. It makes sense that they're over 3 because my reference angle is 60 degrees. So we found the values of theta between 0 and 2 pi. Both of these are less than 2 pi because that would be one full rotation around. We found the values of theta such that the sine of theta was negative square root of 3 over 2. And I knew I was in quadrants 3 and 4, because that's where sine is negative. In quadrants 1 and 2, sine is positive.